Okay, now we're on to our next talk from LEDs, a hard handbrake turn, if you want to describe it that way. We're now going to get a talk from Nicola Donato from Green Gas and Liquids. It's talking about CO2 and CEA. Nicola, over to you. Looking forward to hearing this.
Thank you. Thank you for having me here today. I will be giving you a little different perspective on how CO2 capture can be used in greenhouses, and how it can really increase the efficiency of how we utilize CO2 in greenhouses, and take really advantage for the growers, take advantage of becoming self-sufficient sometimes on the one of the main component of their suppliers. So today we know more than ever, probably in this period, how volatile the energy market is. And the greenhouses are really exposed to all these headwinds, with including also increased cost of labor, emission control, and the acknowledgement as well that greenhouses produce a staple product, a product that is every day on the shelves of the supermarket, and it needs to remain affordable for the good of everyone out there. So it's more than ever important that we keep this in mind, as these industries, because they are now industries, horticulture sector, they need to face all these headwinds, but they need to still produce some product that is affordable for the people. And more than ever, it becomes more important for growers to become self-sufficient, de-risk all these geopolitical risks that are out there, and they are creating an impact on their cost of production. So it's more than ever important to focus on lowering cost of produce. Now, CO2 is a very fundamental part of all of the greenhouses that produce fruit and vegetables with more importance, but also many other cultures out there. And in this picture, in this graph from the Wageningen Institute, you can clearly see how the CO2 injection in greenhouses can bring between 10 to 15 to 20 to 25% more production when injected in the right time, and therefore this is obviously also impacted by the radiation level, the concentration of CO2, and how this remains and is absorbed by the plant. But this really could strike a big difference for the growers, as injecting could signify 10 to 25% more crop. Now, CO2 is today supplied either externally with liquid CO2 available on the market. However, it does suffer from a number of seasonal instability. We all know how liquid CO2 becomes less available in summer, when there is a large use by the beverage industry and the food industry, and it becomes less available for the horticulture sector, where this is exactly the season where is most important. Plus, a lot of the liquid CO2 has an origin of fossil origin, and therefore its price is directly connected with the primary resource, which is the fossil fuel, and the electricity consumption that is used for the production of it, as well as the supply chain that is also connected with the transportation. So it continues to experience an increase in price. it's by for sure the higher quality CO2 in terms of grade, but it comes definitely at a cost. Another possibility is to internally supply it by burning natural gas, for instance, in a CHP or in a gas boiler within the infrastructure of a greenhouse. However, this may suffer from a specific imbalance as we want to produce the heat when it's most needed at night, especially in summer. But we need the CO2 when it's most needed in during the day, as well as during when while using a CHP. Today, more than ever, we face the reality that the electricity production during the daytime is really affected by the low prices, as the solar power and the wind generation produces a lot of power in those sunny days and summers. So it puts at strain a little bit the use of CHP, as the electricity production is not so profitable, and it always has a challenge of, am I producing enough CO2 for my tomatoes or so, and can I produce it at this time? So there is always this mismatch. Today, I want to show you how this can be done in a little bit different fashion, in making use of a technology that is the carbon capture technology that has been adopted and a little bit tailor-made for the horticulture sector. This is a carbon capture technology that allows you to operate your energy source whenever you need it, and store the CO2 in its pure form and at a 99% purity, almost like if it was liquid CO2, but keep it in its gas form, in a balloon-like shape like this, and really making use of your own CO2 that you produce in-house whenever you run a gas boiler, whenever you run a biomass boiler or a CHP, in the hours in which it makes most sense for you to produce energy, and store the CO2 and inject it when it makes most sense for for the growers to inject it. Hope I was able to pass right the message of how this technology has been really tailor-made now for the horticulture sector. And this is a picture that you see here is one of the oldest standing plants since 2019 in the Netherlands, feeding CO2 to 24 hectares of tomatoes, aubergine, and bell peppers. So shifting with CO2 capture and the Galaxol technology, you can really shift the CO2 volume from night to day, and you are able to really capture the CO2 at night when maybe the CHP has most profitability, and inject the CO2 in the morning when it makes most sense, right? So takes the benefit of the uh, higher price of electricity at night, and the lowest price of CO2 in that moment for the production, right? Maintaining always a very high quality of CO2 grade with a 99% purity. Yeah. So how does this technology works? Regardless whether you're using a biomass boiler or a CHP as a gas boiler, we take over the flue gas coming out of this energy generation part. We condition it, we clean it, we have an absorption cycle that, with a proprietary solvent, is able to separate the CO2 and produce a stream of pure CO2 to be stored in its gas form. Why in its gas form is simply because there is no need for a grower to invest into expensive liquefaction as it is used on site, the majority of it. The liquefaction is definitely possible, which opens up obviously a number of other applications where the grower can utilize its CO2. But that's a little bit in a quick scheme how this can look like, and how it works. Every source of energy that is anyway recovered during the process is sent back to the heat buffer tank that is utilized for the grower. Now, the benefits of this technology really are connected with the fact that it can capture most of the CO2 that the growers produce itself. It's really tailor-made for them in terms of capacity and CO2 purity that are designed for, and it utilizes a biodegradable solvent that puts no risk on potential environmental risks connected with the use of this solvent and the location of food producing industry. It is proven with a number of different plants already active for a number of years. And it has been proven to really have a low operational cost with CO2 costs that can go as low as 20 to 25 euro per ton, and therefore really drastically reduce the cost of acquiring your CO2, and also becoming self resilient, as we said from the start, right? So this is, as said, an installation active since 2019 in the Netherlands, feeding 24 hectares. And this is a second one active since 2021 as well. And the last one that we recently commissioned in Vienna, Austria, producing 1.8 tons per hour of CO2. Clean CO2 to feed around 7 hectares of greenhouses in Austria, in Vienna, Austria. So that's speaks for the proven technology, and really gives you a perspective of how a technology that has rather being used for other applications now has found also different niche markets to support the horticulture sector and the greenhouses, as we do see they play still a really very important role in this society, and they need to continue to be supported by technology, governments, regulators, to really strive to produce better and more efficiently, and satisfy the needs of every of the people out there. Yeah, that's all from my side. Maybe I was a little faster than you expected.
Yeah, that's fine. That's fine, Nicola. Okay. No, it looks really interesting. The picture at the end that captured my imagination, and the thought was, once you have one, once you start to, if it boosts productivity, you might think, I'll build more glass houses. So is the CO2 system scalable, or you have to buy it or build it within a CO2 production window?
Let me understand if I get this. Maybe you can repeat it again so
Well,
that
say I doubled my glass house footprint.
Yeah.
Would I be able to then scale up my CO2 system to cope with that?
If you build a new one, you mean?
Oh, right. Do you have to build a new one, or is there a scalable window within the existing one?
Well, normally these type of systems are you keep into account a certain level of over design.
Yeah.
Right. So but obviously, if you double your greenhouse surface, then it might be more difficult to do
Okay,
that.
no, that's fine. Simple
That gives you
question
an
people
idea.
would answer, yeah. So how does on-site capture compare in cost and reliability to buying in liquid CO2? I mean, I will preface this with in the UK, we've just opened a bioethanol plant specifically to supply CO2 in the UK.
Yeah.
So that, I may have answered my own question there, but what's the comparison between your system and just buying it in liquid CO2?
Liquid CO2, right? Look, liquid CO2 has the price of liquid CO2 really depends on your location and the distance from the point of production.
Yeah.
I can tell you there are islands in the world that pay astronomical prices because they don't have access to it. But you can think also that if you are in the mainland, very close to to a hub of production of CO2, the cost of CO2 is fairly connected with the gas price.
Yeah.
The gas price makes a very big bulk of it, and then the second one is your transportation.
Yeah.
So you have an idea. Now, what comes into play a lot is, for instance, in Europe, the use of carbon tax.
Yeah.
This adds on top of the existing prices as well, and really puts a strain with prices that I've seen in the market ranging even above 200 euro or $200 per ton.
Yeah.
With a production like this, we have seen you can really drastically reduce the price, provided that you really need the heat and you are in an area like the UK or the Canada or the Netherlands as well, but the Nordics, where you are producing anyway the CO2 for heat source. And then in that case, it can really go down to an order of magnitude less. So you're 10 times less cost than you would have with a liquid CO2. So it's a little bit.
No, it's fine. So thinking on the details of it, and I'll go back to, again, that picture you had and back to my background. Well, I'm still a chemist.
Yeah.
Well, exactly that. So presumably within these, and I think from the cartoon was really nice. So you had adsorbents or basically a scrubber system in there as well. So you're not adding, so you end up just adding CO2 and not other N2Os or anything else generated from the burning, from the CHP system. So that's the absorber desorber. Was that just for, is that for cleaning the CO2?
That is only for the absorber desorber. This one that you see here is only for the CO2 capture.
Okay.
And it's really done with our proprietary solvent with the biodegradable solvent. As we understand, growers cannot handle the toxicity of petrochemical solvents. So we really made something custom made for that.
Okay.
And the advantage of this is really you also inject in the greenhouse a CO2 that is free of NOx, free of ethylene or any other impurities. And we recently actually received the good report where already our gas CO2 coming out of this process was already compliant to beverage grade CO2. So that speaks already for the level of purity that it can be achieved.
It's almost close to biogenic CO2.
Yeah, it's depending on the source of it, it can be seen as that. Yeah.
Okay, that's cool. And presumably, if someone is buying in liquid CO2 and goes for this, it would integrate with their existing system.
Fully. Yeah, fully, because you are going to evaporate that CO2 and it's going to be 100% pure, and this is exactly integratable in the same ecosystem.
Cool. Well, I think certainly under current markets, you'll have several converts today. So I look forward to people contacting you. If you're interested, please reach out to Nicola. His details will be in the networking section at the back and the last slide here, probably, I suspect.
Yeah.
So, Nicola, thanks for the talk. Really interesting. Nice to hear something very different from that side. And CO₂, as I say, the uplift in biomass, particularly in CEA crops, is huge. And so, good luck to you. And we look forward to hearing more from you in the future.
Yeah. Thank you. Thank you. Have a good session.
Thank you. Bye.